Hello, today we're going to talk about tolerance, clearance, and interference. If you are a machinist, you may see drawings like this that are showing how tolerance works with maximum and minimum dimensions. Or if you are a automotive person watching this video, you might have dimensions in your specifications that look like this: negative 0.75 degrees plus or minus 0.5 degrees. That's talking all about tolerance, clearance, and interference. So we need to define a few things first. Tolerance is the amount of variation permitted on the dimensions or surfaces of manufactured parts. So it's the amount of variation permitted on the dimensions on the manufacturing parts. Or if you're an automotive person, it's how much variance you are allowed to have and still be within specs for the car. The limits are the extreme permissible dimensions for the part. We're going to talk about maximum and minimum limits. So if we have a maximum limit of a hole diameter being 0.875 inches and a minimum limit is 0.872, to find the tolerance between those two, we're just going to subtract them. And we just got done talking about subtraction of decimals, so you should be able to subtract these decimals and get 0.006. So 0.006 is, or 6/1000ths, is the amount of wiggle room that you are allowed to have in that part. A basic dimension is the standard size from which the max and minimum limits are to be determined. So this is how it should be, okay? And then we have things that are called unilateral tolerance, which means that the total tolerance is taken in one direction from the basic dimension. So either you're allowed to get the dimension is allowed to get bigger, or it's allowed to get smaller, but it's not allowed to get both, okay? Bilateral tolerance means that the tolerance is divided partly above and below the basic dimension. So bilateral means that you're allowed to take tolerance off the minimum end and off of the maximum end. So the part shown on page 108, we are on page 108, is dimensioned with a unilateral tolerance. The dimensions are given in inches. The basic dimension is 3 75/10,000ths of an inch. The total tolerance is a minus, or a negative tolerance. And find the maximum permissible dimension and the minimum permissible dimension. Okay, so what this means, this is unilateral, meaning that this amount of change is only coming off of the negative side, the minus side, not both of them. See how it says plus 0 and minus 16/10,000ths. So for the maximum dimension, or we call it the maximum limit, we're not adding anything to it because it says plus 0. So it would be 3.7500, and these are in inches. And the minimum we would then find by taking 3.75 and subtracting this amount. and we would get 3.7484 inches. So this dimension right here is allowed to be as large as 3.75 inches or as small as 3.7484 inches. When you're working with pieces that fit tightly together, these dimensions, even though it's a very small change, it could mean the difference between a part moving smoothly and freely through with another part or getting jammed up. Our next question here shows a dimension that has a bilateral tolerance. So the bilateral tolerance, see this plus or minus, means that we're adding and subtracting 0.04 off of that measurement. So to find the maximum limit, we would take our dimension 62 and 79/100ths, and we're going to add 0.04 to it. That's our maximum limit. To find the minimum limit, you would take your dimension and you would subtract 0.04 from it to find the minimum dimension. So this part, the distance between those two holes, is acceptable to be anywhere from 62 and 83/100ths to 62 and 75/100ths, and still be within specifications for the part. So the next thing we need to talk about is the fit of mating parts. And in other words, the clearance between the two moving parts. It's when one part is to move within another, there is a clearance between the parts. For an example, in automotive, when you have a piston moving in a cylinder, there's a clearance between those two parts. When one part is made to be forced into another, that means that there is interference between the two parts. It is so tightly put together that it causes interference. Allowance is the minimum clearance or maximum interference, between the mating parts. So our example down here shows what it looks to me like a piston going into a cylinder or a peg going into a hole. This is your hole. This is your hole here, and your diameter. This is your shaft piece going down into the hole. Okay, so when it asks the question, what is the maximum shaft diameter? It's talking about this piece right here. This is the shaft measurement. So the maximum means that we're going to take 0.7502, and we're going to add the 0.008 tolerance to it. So that's the maximum it would be allowed to be. That's the maximum shaft diameter. The minimum shaft, just working the tolerance the same way, we're going to take this measurement and subtract the 8. So the minimum the shaft can be is 0.7494. If we talk about the hole is looking at these measurements down on this end. So the maximum that the hole can be is 0.7536 plus the 0.0008. That would be the maximum it could be. The maximum hole diameter is 0.7544. I should have made these different colors so that we could see them. That these top two belong to the shaft, and then the bottom two are going to belong to the hole. The minimum hole diameter means that we take the hole, the measurement of the hole, and we subtract our tolerance, just like we did in some of our other problems here, 0.7528. And to explain what clearance is, I want to switch over to another piece of paper. So just bear with me, I'll be right back. Alright, so maximum clearance between these two parts would be the amount of room in between the moving parts. The maximum happens when the hole is at its largest and the shaft going into it is at its smallest. It would create the most wiggle room between the two parts, the most space between the two parts. So you find the max clearance by taking the maximum size of the hole minus the minimum size of the shaft. So the maximum size of the hole from our problem was 0.7544 minus the minimum of our shaft, 0.7494, and we subtract those, and that will be the maximum amount of clearance that can happen between those two parts. The minimum amount of clearance, and I actually kind of want you to think about this, the minimum amount of clearance happens when the hole is as small as it can be, but the shaft going into it is at its maximum and it's the largest. Do you see how that would create not as much wiggle room? That's why this would be the minimum clearance. And you take the minimum clearance by finding the maximum dimension of the shaft and the minimum dimension of the hole. And I really wrote those backwards. That's going to create a negative number, but we don't really record it as a negative number. It will be okay to just subtract it. And our minimum amount of clearance would be 18/1000ths. So the maximum amount of clearance that we have in our two parts here is only 500ths. That's a lot of space, 500ths. That's a big measurement in comparison to the minimum amount of clearance is 18/1000ths of an inch. Alright, so I would like you guys to go ahead and try the questions on your Google quiz. You can always refer back to this video, keep the video open in another window if you would like, but you're doing questions about tolerance, bilateral, and unilateral, and then you're also doing questions about clearance and fit. I hope this video helps you understand what clearance and fit is, and by any means, if you have any questions, please email me at cjones@ictc.edu. All right, have a great day. Hope to see you soon. Bye.